Graphs of the reciprocal functions. To sketch the graph of a secant or a cosecant function, what we're going to do is first make a sketch of its reciprocal function, then find the reciprocals of the y-coordinates to obtain the points. The x-intercepts of the sine and cosine functions, really important, become vertical asymptotes of the cosecant and secant functions. So we're going to sketch a secant graph. We need to think about sketching the y equals cosine of x. The reciprocal secant is cosine. So the full period of a secant is 2 pi, so 2 pi, pi over 2, and 3 pi over 4. I'm stretching it a little bit. Then this is negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. 1 and negative 1 for our y-axis. So cosine starts at the amplitude. So it starts at 1, and then down at pi over 2, then pi is at here at negative 1, then 3 pi over 2 in the midline, and then 2 pi, we're back at the max. Then you could just go backwards to fill out the rest. So at the x-intercepts, they are undefined. Just think about evaluating secant of pi over 2. So just think about 1 over cosine of pi over 2. And we know that's 1. Cosine of pi over 2 is 0. And so notice that it's undefined at that point. So all of these become our vertical asymptotes. So just draw it. Then what happens is those top points, the maximum and minimum points, become the other parts of the graph. So we just flip everything. So it goes that way, and then this goes down. So the top points, it opens up, and the bottom points, the minimum points, it opens down. So that is a graph of a secant. So the cosecant graph is very similar to that. So we're going to graph y equals sine of x. So do the same thing. So this is pi over 2, 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2, and 2 pi. 1 and negative 1. So thinking about sine starts at 0, then up at pi over 2, down at midline at pi, and at negative 1 at 3 pi over 2, and then here we're at 2 pi. Then we can just back it up. So that is our sine graph. Again, we have our vertical asymptotes at the x-intercepts. So if you think about, let's say, just say sine 1 over sine of 0, that is 1 over 0. So it's undefined at that point. Then at the maximum points, it just opens up. And minimum points of the sine graph, that's when it opens down. So it should alternate when you are graphing. So you're going to fill out the entire coordinate plane. So we're going to sketch the graph of y equals 2 cosecant of x plus pi over 4. So we're just thinking about graphing the sine graph and then the shifts and then vertical stretching and shrinking, put the dots, and then you flip it to be able to graph the cosecant. So let's look at it shifted left pi over 4. Let's figure out the one interval. So again, you set this piece inside to 0 and to 2 pi to solve. So x plus pi over 4 equals 0. And x plus pi over 4 equals 2 pi. So subtract pi over 4. We know that the left side is negative pi over 4. On the right side, we're going to subtract pi over 4 from that. And then so that becomes 8 pi over 4 minus pi over 4. So it's going to be 7 pi over 4. Okay. Now we know that a full period of a sine function is 2 pi, so let me just start with that. 2 pi, pi, pi over 2, 3 pi over 2. Then I notice that I have to shift pi over 4 to the left. So I need to go negative pi over 4. So that tells me that I need to change some of my other numbers. Or I need to add more numbers, so that's why I stretched it out. So then my next point is going to be at pi over 4. This is going to be 3 pi over 4, 5 pi over 4, and 7 pi over 4. and then this is a 0 here. And we're graphing cosecant, and the amplitude, well, we think of sine, right? 2 sine of x plus pi over 4. We know that the amplitude of sine is 2, so it's 2 and negative 2. So we're going to start. Sine starts at the midline. So here, negative pi over 4. Now then I have to go up here at positive pi over 4. Then 3 pi over 4, I'm done at the midline. At 5 pi over 4, I'm at negative 2. And at 7 pi over 4, I am back at the midline. So then I look at my interval. That should be one interval, negative pi over 4 to positive 7 pi over 4, and that is correct. Then, of course, I could back it up to fill out the rest of the graph. Okay, so that gets more of my graph. And all of the x-intercepts are my asymptotes. Okay, and then of course you should fill in the rest of the x-axis here. So negative pi over 4, negative 3 pi over 4, negative 5 pi over 4, and negative 7 pi over 4. Then we know that at the maximum, that's where it opens up. And over here, it opens down. And then this is also down here, and then up here. Okay, so you'll have nothing in the center there for this graph. So go ahead and try the next example, 2 cosecant of x plus pi over 2. So here's a graph of 2 cosecant of x plus pi over 2. It shifted left pi over 2, so that was nice because it was within the normal period, and we didn't have to add more x labels for our x-axis. So do the last example, and let's do the last example, y equals secant of 2x. So we're looking at cosine 2x. The only thing that changes here is the period. Remember, the period is 2 pi over b for sine and cosine. So this is 2 pi, b is 2, so therefore the period is pi. So this is pi over 2, this is pi over 4, 3 pi over 4, and then we'll back it up. Negative pi over 4, negative pi over 2, negative 3 pi over 4, and then negative pi. So cosine is, we'll do 1 and negative 1, starts at the amp. So 1, down, down, up, up, and then down, down, up, up. Okay, so hopefully it's really good to know the patterns of sine and cosine. Then our asymptotes are at the x-intercepts. Then it opens up at the max points and down at the low points. And then you fill out the entire graph there. So try this last example on your own. Graph y equals secant of x over 2. So for this last example, you're just graphing cosine of x over 2, just those dots, important key points. We know the period is 2 pi over b, which is 2 pi over a half, which ends up being 4 pi. So then I start with 4 pi and then divide it in half. Half of 2 pi is pi, and then this last one is 3. And then I back it all the way up, label my x and my y-axis with 1, and that should be a negative 1. And then graphing cosine starts at the amplitude here, and then just doing the pattern up, down, down, up, up, and then go backwards, and then draw the asymptotes and so forth.